A disphenoid is a tetrahedron whose triangular faces are congruent to one another. What is the least total surface area of a disphenoid whose faces are scalene triangles with integer side lengths? A tetrahedron has four triangular faces. The surface area will be minimum when the surface areas of the triangles are minimum. That will happen when the triangles have the smallest possible sides. It is given that the triangles are scalene triangles, that is, the lengths of the three sides are unequal. The smallest sides could be 1, 2 and 3, but this is not possible because 1 plus 2 is not greater than 3. We know from the properties of triangles that the three sides are such that the sum of any two sides is greater than the third side. If the sides are 1, 2 and 3, then sum of the sides with lengths 1 and 2 equals to 3, which is not greater than 3. Therefore, 1, 2 and 3 will not constitute a triangle. Similarly, sides 1, 2 and 4 and 1, 3 and 4 will also not do because 1 plus 2 is not greater than 4 and 1 plus 3 is also not greater than 4. The next higher size is 2, 3 and 4. Let us check this. 2 plus 3 is greater than 4, 2 plus 4 is greater than 3 and 3 plus 4 is greater than 2. That means sum of any two sides is greater than the third side. That is another property of triangle which is related to the first property, and that property is the difference of any two sides is less than the third side. And if the sides are 2, 3 and 4, then the difference of 4 and 2 is less than 3, difference of 3 and 2 is less than 4, and the difference of 4 and 3 is less than the third side too. Therefore, the difference of any two sides is less than the third side. Therefore, the sides 2, 3 and 4 will do for a triangle, and since the three sides are unequal, this is a scalene triangle. Semi-perimeter S of this triangle is 2 plus 3 plus 4 divided by 2, that is sum of the three sides divided by 2, and that is equal to 9 by 2 or 4.5. Now, if we denote the side lengths 2, 3 and 4 as A, B and C respectively, then S minus A is equal to 4.5 minus 2, that is equal to 2.5. S minus B will be 4.5 minus 3, and that will be 1.5, and S minus C, that will be 4.5 minus 4, and this will be 0.5. Now the Heron's formula for the area of a triangle with sides A, B and C is given by area, that is T, is equal to square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. In the present case, area is equal to, since you have found out S, S minus A, S minus B and S minus C already, we just put in those values to get square root of 4.5 multiplied by 2.5 multiplied by 1.5 multiplied by 0.5. And since 0.5 is present in all the four terms, we take it out in the following manner, that is square root of 0.5 into 9 multiplied by 0.5 into 5 multiplied by 0.5 into 3 multiplied by 0.5 into 1, which is equal to 0.5 raised to the power of 4 multiplied by 9 into 5 into 3 into 1. And if you take the square root, we get 0.5 whole square multiplied by square root of 9 into 15, which is equal to 0.25 multiplied by 3 square root of 15. This is the area of one triangle with sides 2, 3 and 4. Hence, the sum of the areas of 4 such triangles is 4 multiplied by 0.25 multiplied by 3 square root 15, which is 3 square root 15. So, this is the surface area of the disphenoid. So, the answer is 3 square root 15. The disphenoid is shown in the diagram. Note that it is a three-dimensional figure, that is, the vertex D is not on the same plane as that defined by the vertices A, B and C, but it is raised upwards. In this video, we will solve another problem, and that problem is 20 numbers have a mean of 45. If all the sixes present in those 20 numbers are removed, the mean becomes 66. So the question is, how many sixes were there in the original 20 numbers? Let there be n number of sixes in the 20 numbers. Now sum of all the 20 numbers is 45 into 20, because the mean is 45 and the total numbers is 20. So the sum of all the 20 numbers is 45 into 20, that is 900. Let the sum of n number of sixes be 6n. Then sum after removal of all the all the sixes is equal to 900 minus 6n. The number of numbers after sixes are removed becomes 20 minus n. It is given that the remaining numbers have a mean of 66. That means 20 minus n numbers have a mean of 66. Then the sum of these 20 minus n numbers is 66 multiplied by 20 minus n, that is mean multiplied by total number of numbers. So if you multiply this 66 into 20 minus n and 900 minus 6n, which is also the sum of the numbers after all the sixes are removed, then these two should be equal. Or we can write 900 minus 6n is equal to 1320 minus 66n, which is obtained by simplifying this term. So we get 60n is equal to 1320 minus 900, that is 400, 20. So n is equal to 7. Therefore, the number of 6's present in the original numbers were 7.